Good afternoon. Good morning to those of you on the West Coast or in Hawaii. This is S.K. Ghosh. I would like to welcome you to our web seminar today on structural irregularities. Okay, with that, I will start into the seminar. The title I have shortened into structural irregularities. What we will talk about is how we are how we account for structural irregularities when we design by ASCE 7, which is adopted by the IBC. The seminar is specifically based on ASCE 710, which is adopted by the 2012 and 2015 IBC. However, if something has changed in ASCE 716, which is adopted by the 2018 IBC, I have indicated that in the seminar. You will see that those instances are rare indeed. Almost nothing we will talk about has changed from ASCE 710 to 16. At the beginning of the seminar, we will talk about earthquake experiences with irregular structures. I think that forms a proper backdrop to the subsequent discussion. Then we will talk about horizontal structural irregularities that are in ASCE 7 and how we deal with them in design, followed by a discussion of vertical structural irregularities and again how we deal with those in design by ASCE 7. Now, in this discussion of irregularities, the term that will keep on coming back is configuration or structural configuration. Configuration is relative arrangement of parts. Uh, that's pretty much what it is. Regular relative arrangement of the parts of a structure. Okay, that would be structural configuration. We talk about horizontal configuration, how parts are arranged in plan. We also talk about vertical configuration, which would be how parts are arranged as you go up the height of a building. Both have influence on structural response to an earthquake, and this is why both are of interest to us. As I just said, the configuration of a structure can significantly affect its performance during a strong earthquake that produces the ground motion contemplated in IBC or ASCE 7. So I have one example in the picture from the Mexico earthquake of 1985. You see that it is an L-shaped building. That was not the only factor that doomed the building, but it definitely contributed to what happened to the building. So the configuration of a structure can significantly affect its performance during a storm. What I said on this slide is very important. So the ASCE 7 seismic design provisions, which kind of have evolved from what we used to have in the Uniform Building Code or the SEOC Blue Book. The provisions were developed basically for regular buildings. There is no question about it. We have ample records to tell us that that's the way it was. Past earthquakes have repeatedly shown that irregular buildings suffer greater damage than regular buildings, immeasurably greater. Irregular buildings have a tendency to basically attract damage to themselves. You see it whenever you go after an earthquake. This happens even with good design and construction. Okay, so an irregular building does not have to be poorly designed or poorly constructed for it to attract earthquake damage. I have included a few examples of uh, seismic response of structures in past earthquakes. First one, And I will probably skip the word slides. So this is the so-called Loma Prieta earthquake of 1989 in the San Francisco Bay Area, in the so-called Marina district of the city of San Francisco. We had a number of buildings like this. Actually, many of the buildings are like this. These were, first of all, built on fill.